Okay, let's start with number 1. Okay, moving this over. All right, so how would we simplify the square root of a negative 54? Well, the first thing that we would need to do is split it up into a negative 1 and a square root of 54. So to do that, what is the square root of negative 1? Hopefully everybody will tell me I. And then let's split up 54. Is there any perfect squares under 54? Well, yeah, there's a 9, and 9 times 6 will give us a square root of 54. So what's the square root of 9? Well, hopefully you'll say 3. Is there any perfect squares under the square root of 6? No, so that's just going to stay under the radical, and it'll be 6. Now we got to put this all together. 3 square root of 6. So remember, the i's get squunched in the middle of your real number and your radical. So then this would be your answer. Okay, so let's look at number 2. So on this one, you can't really simplify 42. Well, let's see. Let's divide that. Not very well. It will be a fraction. It'll be 14 over 3, which would not help us any. So what we can do here is we can split up the square roots. We can give it to the top and to the bottom. Well, what's the square root of 9? 3. So yay, we get rid of that radical underneath the denominator, which we're not allowed to have. So now we have the square root of 42. Well, we can split that square root of 42 into a square root of negative 1 and a square root of 42. What's the square root of negative 1? I. And let's see, what's the square root of 42? Is there any perfect squares under there? There's 4, doesn't work. Let's see if 16 works. Nope. Okay, I don't believe that there's any perfect squares. So 4 divided by 2 is 21, and 21, if you break down that, it's 7 and 3. So that doesn't work. So then our answer, let me get my blue back again, is I square root of 42 all over 3. And then we're done. All right, number 3. Okay, so remember, you cannot add a real number to an imaginary number. So we're going to have to simplify this 72, well, square root of a negative 1 times square root of 72. So this becomes an I, and can we break down 72 by anything? Well, yes, 72 and 9 is 9 and 8, but then there must be something bigger than that too. So let's see what it is. 72 divided by 36. So 36 times 2, so the square root of 36 is 6, and square root of 2, you can't do anything else with that, so we get negative 9 plus 6i root 2, and then that is our answer. Okay, let's go look at 4. Now we talked about 4 being, remember it was, the pattern is I1, negatives in the middle. Remember that was our pattern. So I is I to the first, this one is I squared, this one is I to the third, and this is I to the fourth. Now we talked about this is a pattern of 4. So you can get with 4 and then you can start over again with 5, 6, 7 and count like that. So if we do that, we count 1, 2, 3, 4, and then we start over. 5, 6, 7, 8, count over. 9, 10, 11, 12, 13, 14, 15, 16, 17. So we get 17 is I. So what if we didn't want to do that every time? There's another way that we can do this, and it might make a little bit more sense, but do it whatever way that you want to do. So we could divide 17 by 4 because the 4 is repeating. We're repeating by 4s every time. So ask yourself, how many times will 4 go into 17? Well, hopefully you'll say 4 times, and 4 times 4 is 16. You remember this is like second grade math right here. So then you subtract these and you get a remainder of 1. Well, now look, that remainder of 1 is associated with that 1. So what would that be? Well, that would be just I. So then your answer is I. You get the same thing whichever way you do it. So now let's try 5. Let's do it the same way that we did before. Let's divide. So remember, I1, negatives in the middle. So this is equal to the I to the first, I squared, I to the third, I to the fourth. So now 98 divided by 4. How many times will 4 go into 9? Well, hopefully you would say 2 times. So 2 times 4 is 8. So subtract, bring down your 8. How many times will 4 go into 18? 4 will go into 18 4 times. So 4 times 4 is 16 with a remainder of 2. So then that 2 is associated with that 2. So the answer would be negative 1. Okay, next. Okay, we'll just stick with this I1s over here. So division. So 4 divided by 203. So how many times will 4 go into 20? 5 times. That would give us 0. So then bring down your 3. So then how many times will 3 go into 4 go into 3? 0 times. Remember, you've got to do this. So how many times will 4 go into 30? Let's see, how many times will 4 go into 30? 8 would be 32, so that would have to be 7, and 7 would be 28. So 28. Let me do this. Divided by, we could do this in our calculator, which would probably be easier. Let's just do that. Okay, somehow I messed up along the way. All right, let's do this in our calculator. Start over. Okay, 203. Do this in your calculator. When I did 203 divided by 4, I got 50 something. Well, 4 times 50 is 200, which gives us a remainder of 3. Wow, that was so much easier. So now we have 3 is associated with that 3, so the answer is negative I. Yay! Okay, so if you don't like this, do it the old way. You can count if you want to. You can find multiples of 4, whichever way that works best for you. Okay, let's keep moving along. Wait, I think we did this one in class, but let's just make sure. Remember, this is not a multiplication problem. This is a subtraction problem. So we need to distribute that negative to each term. So we're not multiplying these, we're distributing. So we get 24 minus 11i minus 3 minus 13i. And we're going to combine like terms. So 24 minus 3 gives us 21. And then combine the i's. The negative 11i minus 13i, this is going to give you a negative 24i. And then that's your answer because we're in standard form. We got the real number and then your imaginary number. There's that. Okay, this one, we do multiply. It is a multiplication problem, so we FOIL. So 6 times 3 is 18, plus 6 times 8i is 48i. Negative 2i times 3 is a negative 6i. And a negative 2i times 8i is a negative 16i squared. So now let's combine like terms. So 48i minus 6i is going to give us 42i. Now we've got to deal with this I squared. So remember, I squared is a negative 1. So substitute negative 1 in there for that I squared. And then we get 18 plus 42i plus 16. Now combine like terms. 18 plus 16 gives us 34 plus 42i. And we're in standard form, so we're done. Okay, 9. Distribute. So we get negative 18i. No, we don't. We get negative 27i minus 18i squared. So we've got to deal with that I squared. Negative 27i minus 18 times negative 1. So you get negative 27i plus 18. But this isn't in standard form. Remember, it's real number, then the imaginary. So you get 18 minus 27i. Okay, number 10. So I'm going to deal with this first. So what this means is you're going to write this twice. So you get negative 6i times negative 6i. Well, what does that give you? Well, hopefully you'll say 36i squared. So go ahead and let's do this one now. What is negative 5i times 5i? Well, hopefully you'll say negative 5i squared. So go ahead and deal with these I squareds. So 36 times negative 1, and then we have negative 5 times negative 1. So that's going to give us negative 36 times a